All right. So I would like to introduce a project of mine. It's called meta-codechecker, and it's about static analysis for your Yocto-based project. And I'll show you how it works and how you can easily use it. Quick intro. I'm Jan-Simon Möller. You find me on Freenode and wherever else using my ham radio call sign, which is DL9PF. If I'm not doing ham radio, I'm the release manager for AGL. And I'm also serving in the Yocto and Open Embedded Board. So if you have any questions, reach out. So this talk is about static analysis. What is that? I'll show you a few tools, just a quick intro, and then we'll dive into CodeChecker and the Yocto integration, meta-codechecker, the BitBake integration, merely. Summary, and then I'm open for some questions. So let's dive right in. So quick intro, what is static analysis and why should you use it? So static analysis is a method to analyze a program that is performed without actually executing it. So that means we do that usually at build time or standalone. It is more and more important once you go into areas where functional safety is a topic. For example, in automotive, for example, in automation. Now you might say, you know what, my code is always correct. That might be, but in those areas, the product needs to be audited and the auditor needs a way to approve that, right? So this is basically one checkbox in the big list to get your product certified. It is one part. It is not the only solution. It will not solve all problems, right? But it will help to catch some possibly tricky to find bugs. And the goal here is to show how to use this with open source software available. There are lots of proprietary tools that a lot of companies use. I'll focus on the open source part of it. I'll introduce the basics and focus on what we can integrate into BitBake. All right, let's dive in. So first of all, there are a lot of OSS tools available. There are proprietary tools. Some do basically pattern recognition. So they look out for certain, well, strings in the end. Some are using the compiler because, I mean, the compiler does already analyze your source code, right, to compile it. So it is a kind of logic place where this operation can just be attached. And some are simple scripts to check for kind of the usual suspects. In open source, there are plugins or ways to do that with the GCC Clang. But there are also standalone tools with different nuances on what's their main focus. So cppcheck, flaw finder, more on the security issue side, rats, split. So we are not short on tools. The question is how we can integrate those. Today I will focus on CodeChecker, which is associated with Clang. If you want more info how to integrate the other tools, I recommend looking into meta-SCA, just as a side note. So let's take a look. I picked 3, and those are easy for you to use in your local development. GCC 10 gained a new flag called fanalyzer. And fanalyzer will turn on a big number of warnings. So you can use GCC already if you're on GCC 10, and that is kind of more or less already there. Clang has a long history with scan build and clang-tidy. So there are a lot of options to do static analysis with Clang. And a standalone tool, cppcheck. Let's take a quick look. So GCC with fanalyzer will print out this big and well, quite helpful output meanwhile. And yeah, I think that's quite useful meanwhile. clang-tidy. So clang-tidy is using the clang/LLVM tool to find those issues. Output is a little bit different. Clang also has scan build. Now compared to tidy, which is more kind of scanning single files, scan build is doing a full build of a whole project and looking at all headers and going through the full thing, the full build process. And it will generate a report, which, well, if you look at the messages, is kind of the same, but it will also generate an HTML report, which is way more convenient for large projects. And you will get an HTML output like this. cppcheck is a standalone tool, equally useful if you don't want to basically pull out GCC or Clang and just go by source only. That is useful as well in CI environments or whatnot. So we are not short on tools. It's really just a matter of using them. So when I was looking around, I came across references to, sorry, typo, I always write codescanner, but it's called codebase. This is kind of a brain bug that happens all the time. So codebase. I found this, it's on GitHub, hosted by Ericsson and developed by, or further developed by Ericsson. In principle, it's the successor of scan build. So it's scan build on steroids. What does it do? It's a collection of tools that will intercept and log the build calls. So whatever is executed, right? GCC minus something, 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 myfile.c and whatnot. So the whole line minus GCC is logged. Why do they do that? I mean, they need all the flags, they need all the includes, they need all whatnot. So they will log what was called, what was invoked. In the second step, they will analyze it, and they will basically rerun the same call using Clang and clang-tidy and Clang basically scan build. And from there, we can then generate either a static command line based report, static HTML pages, or there is a web UI with a database that can host multiple reports. I was like, cool, let's try that. Okay, standalone, I tried that. Compiling it from Git was a bit iffy because they have, most of it is Python, but there are some kind of awkward bits here and there. But yeah, it worked out. I could scan a project. In the end, basically here is how you call those wrappers. Once it's compiled, you have this code checker wrapper. And first you basically call log, and then your compilation call will make for a whole project. What will this do? So this will preload a little library that will basically just log the compiler commands. And then in the analyze call, they can be replayed, and we can apply clang-tidy and clang-SA. Once the reports are done, they can be parsed to the terminal, they can be parsed into HTML, or they can be parsed into a web UI. And there's a convenient Docker container for that. Okay, I like that. But I want that for my BitBake builds. Okay. This is the web UI. And yeah, it lets you navigate nicely through the issues. Now here is an example for an issue that's like 32 levels deep. Be it now correct, wrong, false, positive, or not, I don't care, but I would have never found an issue 32 levels deep just by staring at it. Okay, so I want that for my builds. All right, let's read the fine manual. They even have a section about BitBake. Let's take a look. And then I saw this. Basically, Widget will now sit back and smile and say, uh-oh. So what happens here? We basically do the preload before we execute BitBake. Might not be the best thing, because what happens, we will log any compilation within the whole project build. So native, everything. So that might not be what I want. I want it per package, right? So I can basically have a report per package, and I don't want native. I don't care, right? That doesn't end up on the target. So, okay, even blind mold wrap can do something. I came up with meta-codechecker. We can write out the HTML reports. We can upload to the database, and all tools are built on the fly. So we are pulling down code, pulling down the Python bits. Of course, there is room for improvement, but so far it works. You'll find it on my GitHub under meta-codechecker. We need meta-clang, meta-OE, and meta-Python for this to work out. So here's a quick step-by-step walkthrough. We need Clang, we need meta-open embedded, meta-codechecker, and of course Pokey. And then we add the layers. Okay, so far, so good. I used the kind of way how meta-SCA works. So you have to include, you have to inherit the CodeChecker class, which will do all the magic. And then you still have to enable it. Yeah, so just inheriting the class will do nothing. You will have to enable it, and as I said, I don't care about stuff that runs on my build machine. So I can enable it only for stuff that goes onto the target. I can also exempt certain packages. I think I built Clang on the thing did not work, so I exempted that. Okay, fine. And in the end, I produced the HTML reports so I can browse through them. Alternatively, if you have set up the Docker container or the server side, you can also upload to the web UI. So, and then you just build your image, and the files will be in temp deploy CodeChecker. So that is how you can use it. As a summary, CodeChecker can be used easily by developers and in CI. The complexity is hidden by the preloaded logger. The workflow is actually pretty straightforward, and you can parse the output into multiple formats. Now, given the how easy you can do that with your compiler alone, I mean, it for quick checks, it's probably way easier to just say -f_analyze or call clang-tidy. But if you want to review the results, or if you want to dig into the different levels and whatever 32 steps deep, the web UI is really good. So what's left to do? Right now, the CodeChecker will basically flag anything, which can be quite a lot, include false positives or stuff I'm completely not interested in. So what needs to be done is we would need to inject a scanner config. So there is some CodeChecker conf JSON, actually like three different ones. One global one, and I think one for each tool used. I didn't dig into that too deeply yet. So we would like to want to say, we only care about X, Y, and Z. Yeah, ignore the rest. Or the uploading to the web UI to the Docker container is currently without token and password. So I will have to add that. Some of the tooling that runs natively is pulled down using PyPy. That needs to be improved. I tried to make a build from Git, but that was a little bit hefty. So I found a way to pull those down. That's not optimal. Yeah. And finally, the content of the layer, if you want to use the Docker container, currently there's a version lock between the two because they need the same API version. So we should probably get some more independent here or create our Docker container ourselves, as we had a lot of nice container talks during the summit. So that might be an alternative as well. So finally, yeah, call to action for everyone. Let's use this to improve our projects. It's easy to use locally for development and for CI purposes. And in our OE builds, we can integrate it in such a way very easily. All right. Any questions